Hello, everyone. Good evening. Welcome for our next session on algebra, functions and graphs. We already have had one session on this. So, I hope you are excited and ready to face the challenge of the questions on functions and graphs. I brought questions again on the current pattern and the current pattern of questions. So last time we looked at questions which were based around graphical approach. Today we'll be looking at more of the equation based questions on functions, and in which functional equations or equations related to the function are there, right? So how does that play a role in problems? We'll look at that. So let's see. Now, first of all India Open CDC Mock 2. So deadline is 1st of August. In case you are not aware, what is CDC? CDC Mock 2 is the real deal, the real feeling of the CAT exam. So sitting around 3 months before the exam, if you are looking to get the real feel of how the CAT exam would feel to us. So go for this. 1st August is the deadline, and there are 45 centers all across the country in which we are arranging this actual CAT uh, style exam. So you'll get an actual in admit card. You'll get to go to the exam 1 hour before, and you'll have the actual feel of how it looks like, how it feels like. So 8th to 11th August, over 4 days it will be conducted, but deadline to register is 1st of August. So go for this, check out the details in detail. I think this is something that is relevant for all the aspirants. Another thing is that CL has come up with its app. So make full use of this. It's something that should be in your phones, just like a lot of other clutter along with that. Something really that would make sense, I guess, for your preparation. So uh, just check out the details. Just check out this on the App Store. The app is live and ready for you to make use of. All right. All that being said, let's enter into functions and graphs. All right. I brought very conceptual questions. Okay. I'll let you read this for a minute and then we'll discuss. All right. Now, in case you get the answer, do let me know. Okay. What does the question say? The graphs of which of the following functions have the property that for each point A on them, a point B also exists with origin as the midpoint of AB. Understanding what this statement means is the first challenge. But challenges are always done with grit and might. Well, so what we have is, let's say this is the coordinate plane. The graph will be there for the function. There'll be some point on the graph. Let's say this is a point A. Another point exists with origin as a midpoint, which means if I join this to the origin and go back the same distance, so that origin is the midpoint of AB, then there is another point that we can get on the same graph of the function. If this point is, let's say, uh, something A comma B, right? This coordinates of this point are A comma B. So what we have done, this origin 0 comma 0 is the midpoint of this line segment AB, which means that the average of the two coordinates are 0 0, which means what are the coordinates of this point? You see, what you have done is basically you have gone down the same horizontal distance as you were above. So you're going to minus A first, minus b first vertically, and then horizontally also you were at plus a, you have gone back the same distance, which is you have gone to horizontally the level of minus a. So the coordinates of this point are what? Minus a comma minus b. Now what does all this have to do with the function, and how do I interpret whether or not this will be true from the equations of the graph, from the equations of the function? You see, what we are describing over here is the very definition of a function which is odd function, a function which is symmetric with respect to the origin. So that condition has been explained in the problem, that okay, I mean, this is an odd function. So the geometric interpretation of that has been presented to us in the statement. So you had to decode that, okay, this question is saying that if the function is f of x, then it should be satisfying the condition that f of minus x should be equal to minus of fx. That is exactly what this means. An odd function, a function in which we input, instead of x we put minus x, we get the value which is minus of fx. A comma b is the point, minus a comma b is minus a comma minus b is also a point on the graph. So we can quickly check with the equations we have which ones satisfy this condition. For this function f of x, what is f of minus x? Replace x with minus x, we get minus x cube over 1 plus minus x whole square will be still 1 plus x square. So yes, minus is common. This is the same as minus of fx. So yes, this does satisfy the condition. What about g of x? So g of minus x will be 2 raised to power minus x plus 2 raised to power x over, right, 2 raised to power minus x minus 2 raised to power x. From the denominator take minus common. So this is, yes, indeed minus of gx, isn't it? By taking minus common from here, minus of 2 power x minus 2 power minus x. So this also satisfies the condition. What about this function log of x plus x cube? Remember, the logarithmic function is not defined when the input is negative. So this function can never be odd, because in order for the function to be odd, it should be defined for negative values of x in the first place. But the domain of this function itself is that x should be positive, because you see we have x plus x cube, which is x into 1 plus x square. That is the input. So x into 1 plus x square should be positive, which means x should be positive. So since the domain of this function itself is restricted to positive values of x, hence this will never be odd. Hence, only the functions f and g are satisfying this condition. Right? So I have basically in this problem, we have been able to appreciate what is the meaning of an odd function. A function in which if x is replaced with minus of x, we get the value which is minus of fx. Right? So, question about symmetric functions was there. Let's see the next one. As I said, questions today are the theme of today is functional equations based problems. Now look at this. Again, I'll give you a minute for you to digest this, and do start trying and let me know if you get this. All right. So this is the functional equation over here, right? F of n into f of n plus 2 plus 1 is 0. This can be rearranged, and basically it is telling us that if fn is known, first of all, this function is a very special function. It is defined only for natural numbers. So for the, if fn is known, that then f of n plus 2 means the value of the function two numbers down the line can be obtained. And then you can see that for the first two natural numbers f1 and f2, the value is given, and we are asked the value of this summation, the sum of the values of the function from f of 101 to 500. These are 400 values, right? These are from 101 to 500. These are 400 values, isn't it? Okay. Can I say this can be just rewritten that f of n plus 2. So this into this is minus 1. So f of n into f of n plus 2 is minus 1. So dividing by f of n, we get f of n plus 2 is basically minus 1 over fn, right? f1 and f2 are the initial values we know. So from there, we can start the writing the chain of values. F of 1 is 2, f of 2 is 5. Further, using this relation, what is f of 3? So putting n as 1 in this, f of 3 is minus 1 by f1. So it's simply minus 1 by 2 or minus 0.5, right? F of 3 is minus 1 by 2. Likewise, f of 4 is minus 1 by f of 2. F of 2 is 5. So this is minus 1 by 5. Okay. The point is, keep on writing the values unless you get a pattern. This question is all about the pattern recognition. What will be f of 5? Minus 1 by f of 3. F of 3 is minus half. So minus 1 over minus half is minus minus plus, and 1 over half is back to 2. We have got back the value of f1 at f5. Wonderful. Nice. What is f6? The same thing will happen to minus 1 by 5. Again, minus 1 over minus 1 by 5 is back to 5. Wow. Wonderful. What does this mean? It simply means that the function is periodic function. The function is repeating its values. The four values that we get, the initial four values, will keep on repeating in a loop because we started with 2 and 5. Again, we are back to 2 and 5. So again, obviously, f7 will be minus 1 by 2. f8 will be minus 1 by 5. The loop will keep on going on and on. So it's a repetitive function. It's a periodic function with a period of 4. Right? Hence, it's very easy to add this. 400 values. We know 4 values will add up to 2 plus 5 plus minus half plus minus 1 by 5. Right? So what is the sum of the function for any 4 values? We can do that. 2 plus 5, 7, and minus half is minus 0.5 and minus 1 by 5. So minus 0.2. 7 minus 0.7. This is 6.3. So this 6.3 is the sum of any 4 consecutive values of the function. 400 values means 100 such groups, right? So 100 groups of 4 values of the function, right, will add up to simply 100 into 6.3, isn't it? So a very nice value, 630 is the required value, right? Pattern recognition, functional equation, and a simple, easy summation once you understand that the function is repetitive. All right, I'm not getting any response, people. I want some response. I want some enthusiasm. Okay, don't just be a passive listener. Come on, join in. Let's jump and solve this question. Okay, let's solve this one. I'm giving you 2 minutes. Okay, I'm giving you 2 minutes on this question, and it's doable. You can do this. Yeah. Yes. Try this. Thank you, Kashvi. You're back. Let's see if you can do this. Okay, I'll start speaking, but still, if you get this, I'm waiting, right? Now, obviously, we have to find y of 1, 2, 3, 4. Obviously, there has to be a pattern, right? This is very similar to the previous one. So we have to trust our instincts, and we have to start finding the values of f, y2, y3, and see what happens. Something will emerge, right? So y1 is given as this, right? F of x. So basically, this is a recursive function, right? Or a composite function, a function of a function. So we have y1 given as this x minus 1 over x plus 1, right? So just start solving. Okay, what is y2? Y2 is f of fx. So wherever you see x, replace it with f of x. So x minus 1 over x plus 1, this much, and then minus 1. Replace x with fx, right? It's a composite function. Whole over, again the same thing, x minus 1 over x plus 1, and then plus 1, right? Wherever you see x, replace it with the same whole expression of fx. What does this work out to be? Yeah, so x plus 1 will cancel in the denominator. I'll have in the numerators for both here. X minus 1, I'm just writing so that it is clear. X minus 1 minus x minus 1 over x minus 1, and then plus x plus 1, right? So here the x's will cancel off, here the ones will cancel off, and this will be minus 2 over x or minus 1 over x. Okay, y3. So we have to keep on doing it until we get something. Y3 is f of fx, means f of minus 1 by x now, right? So wherever you in the original function, wherever you're seeing x, replace it with minus 1 by x. So it will be minus 1 by x minus 1 over minus 1 by x plus 1, which is on the top and bottom multiply with minus sign. So plus here, plus here, plus here, and minus here, because I was seeing a lot of minus values, right? Like this, it is same. So this is 1 plus x over 1 minus x. X will cancel off in the denominator. I get 1 plus x over minus x. Now you can see all these expressions which I'm getting, minus 1 by x, 1 plus x by 1 minus x, are options. So there must be some pattern. Until we hit a pattern, we have to keep on doing. Let's do 1 by 4. Something will happen. Means f of this whole y3, right? F of this whole, which we have got 1 plus x over 1 minus x, is how much? Okay, so in the original function, wherever you see x, replace it with 1 plus x over 1 minus x. So 1 plus x over 1 minus x minus 1 over, again this thing, minus 1. Something will happen. We have 1 plus x minus 1 plus x. Again denominators will cancel off, the same denominators are there, and 1 plus x minus, sorry, this is plus, na, in the denominator, this is plus. 1 plus x plus 1 minus x. In the denominators, the x's cancel. In the numerators, the ones cancel. 2x by 2 or x. Now the pattern will come across, because if y4 is x, then what is y5? Y5 is y is f of y4, and y4 is x. So we are back to fx. So the fifth value is going to be the same as the first value. So there's a pattern of, again, 4 values. Y1, Y2, Y3, Y4 are these values, and then Y5 will be Y1, Y6 will be Y2, Y7 will be Y3, Y8 will be Y4, and the loop will keep on repeating. We have to find Y of 1, 2, 3, 4. So it's a pattern of 4. So you need to divide this value by 4, because whenever you have a value which is a multiple of 4 plus 1, you'll get Y1. Whenever your number over here is a multiple of 4 plus 2, you will have Y2. Multiple of 4 plus 3, you will have y3, and multiple of 4, you will have this y4, which is simply x. So this 1, 2, 3, 4 is a number which is a multiple of 4 plus 2, because we always check the last two digits. 34 is a multiple of 4, 32 plus 2. So yes, what is the one's value? Minus 1 by x. right? So, as I said, trust your instincts. Just keep on finding the things until you hit a pattern, right? So, right? Yes, thank you, Ronesh. Thank you. That is what we got. Right? Little bit time was required. 2 minutes were required. That's why I gave you 2 minutes. So, let's see. Next one. Very conceptual question. And our exam is very logical these days. Questions are coming purely on logic based. So, I brought a question on that pattern where you have to analyze something, okay? You have to do the analysis based on the given statement. Now let's learn through this problem, okay? Something we'll learn. Remember we did the first question in which we did the concept of odd function, right? Let's see what this is. A function y equals fx defined for all real values of x satisfies this relation. So you can see this f of 10 plus x plus f of 10 minus x is 0. Okay, then which of the following statements must be true? There are 4 statements and we have to analyze all 4 of them and conclude which of the following are definitely true. Well, obviously all our attention is on this equation. What does this tell us? Now write it like this: f of 10, let's say minus x, is minus of f of 10 plus x. One, they're the same thing, but still it makes a difference. What does this tell us? You see, there's a function for which he's saying that this is the number 10 on the x-axis. This statement is saying that from this value of x being 10, yeah, Kashvi, similar question was there, but this goes one step more. F of 10, whatever is the value of the function at 10 plus something, okay? So let's say x units down the line, we are at 10 plus x. And whatever the function value is there, f of 10 plus x, let's say this is the value of f of this. So f of 10 minus x, if you will go the same number of same value of x behind 10, you will be somewhere at 10 minus x. The value will be the same magnitude of f of 10 plus x, but with the minus sign. So it will be here. It will be here. So f of 10 minus x is minus of f of 10 plus x. If this value is k, then this value is minus k. If this value is k, this value is minus k. All this discussion is very identical to the idea of an odd function, except for the fact that an odd function is having this symmetry with respect to the origin, but here this function is having this kind of symmetry around the value of x equal to 10, right? So basically this function is something like an odd function, but the symmetry is around the number 10, right? It will look like, the graph will look very much like that of an odd function, just that it will look as if it has been shifted to the right by 10 units, right? For example, something like, for example, maybe a function like y equals x minus 10 the whole cube will satisfy this equation, right? Y equals x cube is an odd function. So y equals x minus 10 the whole cube will look like the shifted graph to the right side by 10 units. This is the meaning of this. This is what you have to understand. Now let's analyze the statements. Look at the first and the last statement. They are definitely anti to each other. They are reverse of each other. The first statement is saying the function has an odd number of roots. The fourth statement is saying the function has an even number of roots. Definitely both these statements can never be true, right? Either one or none of these statements are true. So let's analyze the condition of number of roots. Now look at the fact we have f of this equation. See, whenever we are given a functional equation, it is always valid for all values of x. Okay. Now in this equation, just put x equal to 10 in this equation. Okay, which is valid for all values of x. Sorry, put x equal to 0, not 10, 0. What do you get? You get f of 10 plus 0, so f of 10 plus f of 10 minus 0, so f of 10 is 0, which means twice of f of 10 is 0, which means what? F of 10 is 0, which means x equal to 10 is a root of this graph. This graph must be passing through the point 10 comma 0. You can see the third statement we have proved the graph of the function must pass through 10 comma 0 is one inference which comes very easily by putting x equal to 0 in the equation. F of 10 must be 0. X equal to 10 is one of the roots. Now we are talking from the first and the fourth statement, we are talking about the number of roots being odd or even. Now think about this. X equal to 10 is a root. The graph is symmetric on either side. If let's say the function has the root, let's say 12, I'm just saying randomly, which means the function is passing through 10 comma 0. Let's say, I'm just saying, okay, let's say it is passing through there. We know the function is symmetric on either side. If it is passing through 12 comma 0, which means 2 units down the line it is becoming 0 after 10. So 2 units before 10 it should also have become 0 because it's an odd function, isn't it? It must pass through 8 comma 0. I'm just saying it could be 12 and 8, it could be 15 and 5, it could be right any number on either side of 10 by the same measure. What I'm trying to say is that, do you agree that one root is 10, one of the roots is 10, and except for that the other roots cannot occur on a standalone basis, right? If there is one root 10 plus alpha somewhere, then there must be another root 10 minus alpha somewhere behind. So the roots except for 10, all the roots must occur in pairs. They must be bundled together in units of 2. So there could be 2 roots more, there could be 4 roots more, but it cannot happen that there is one root 10 and there is another root 15 and there is no other root. Impossible. If there is a root 15, there must be root 5. What does that mean? The number of roots must be odd. There is one root which is 10 and the other roots which are in pairs. So the number of roots could be either one only and no other roots, or 1 plus 2, 3, or 1 plus 4, 5, and so on. Yes or no? So the first statement is true. The fourth statement is not true. Now look at the options. We can now do option elimination, isn't it? Because we have definitely got that first and third are true. Fourth is definitely therefore false. Now 1 and 3 must be true. Option A is saying 1, 2, 3 might be correct. Option B is saying 2, 3, 4 could not be possible. We know 1 and 3 are correct. Option C cannot be correct. Option D also cannot be correct because we know we have inferred that 1 and 3 are definitely correct. So second also must be correct. Right. So from the exam point of view, we have got the answer without analyzing statement 2. But for theoretical understanding, let me explain why second is also true. It is impossible that the sum of all roots of the function is 40. So this statement is one step ahead, means this statement is further making use of all that we have just said, right? Roots must occur in pairs. So we are now talking of sum of roots. Look at this, what I'm saying over here. Roots must occur in pairs. If one root is 10 plus alpha, another root must be 10 minus alpha. One root is 10 over here. If there are 2 more roots, their sum must be 10 plus alpha plus 10 minus alpha, which is 20. So the sum of roots, what are the possibilities? It could be either 10, or if there are 2 more roots, then 20 is the sum of these 2 roots plus 10, 10 plus 20, 30. Or if there are 2 more roots, in total 5 roots, then their sum would again be 20. Let's say 10 minus beta, 10 plus beta, again their sum would be 20. So then another 20 would be added, 30 plus 20, 50. So the sum of roots can never be 40. It is impossible because the sum of the roots must be 10 plus a multiple of 20. That completes the full understanding of this, right? Right? So I hope this was interesting, fun, and something worthwhile. Okay, now we'll look at some previous years. Fine. Okay. Uh, a few questions. Let's also see from what we have been asked in the recent years. Um, hmm. Fx is x square minus 7x, gx is x plus 3. Then what is the minimum value of f of gx minus 3x? Okay, go for this, right? All of us know what is composite functions f of gx. We have just done that in some of the previous questions also, right? So I'll give you 1 minute to try this. Well, so if you could get this, do let me know, right? Now, so yeah, so first we have to find the expression for this and then minimize it. So this is quadratic, this is linear. This should also turn out to be a polynomial, maybe quadratic, maybe something else. Let's check out, right? So f of gx minus 3x. So f of gx means wherever you're seeing x in the definition of f, replace it with g of x. So in this equation, replace x with x plus 3, right? So f of g of x and minus 3x. F of gx would be in this equation x square minus cx, 3 x square minus 7x. So replace x with x plus 3. So you will have x plus 3 whole square minus of 7 times of x plus 3 and minus 3x separately, right? So just simplify this. First of all, you have x square plus 6x plus 9 and minus 7x minus 21 and minus 3x. So that's x squared. 6x minus 7x is and minus x and minus 3x, so minus 4x. 9 minus 21 minus 12, a simple quadratic. Arunesh, we don't have to find the roots. The idea is not to find the roots. The question is find the minimum value. See, one thing I've seen, people learn one theory and they think every question is on that theory. So quadratic equation is not just about solving the quadratic. Okay, the question is maxima minima based. What is the minimum value of this expression? Yes, the roots are right. Yeah, yeah, Salim, correct. Right. So you have to do the completion of the squares, right? X square minus 4x. So to do the completion, you have to write over here half of the quotient of x and do the square, right? You get x square minus 4x plus 4 from here. And since there was plus 4 over here, which is being coming across, so you need to write a minus 4 and then a minus 12. So this is x square minus 4x, right? X square minus 4x plus 4 minus 4 minus 60 minus 12 minus 12. So this is x minus 2 the whole square minus 16. So this value, obviously, for minimizing it, this is being a perfect square which is greater than equal to 0. We can put it minimum value of 0 when x is 2. So when x is 2, the minimum value of this expression is this minus 16. Right? Okay, Runesh. Thank you. Perfect. Okay. Let's see the next one. Okay, this came in CAT 2018. Again, let me give you 1 minute for this. All right, so it's a theta question. There are no options to help us, right? Well, so I'm waiting, right? Do let me know if you get this now. So very interesting question, right? The value of a function at a certain input is the sum of the function value at the previous two input values, right? Uh, Actually, this kind of logic, yeah, Harsh, correct, yeah. So this is very famous kind of a sequence. This is called as the very famous Fibonacci sequence, based on the, so named on the mathematician, right? Okay, so a function is satisfying the this kind of sequence, that at any value, the value of the function is the sum of the previous two values of the function. So obviously you need two informations to start generating the values of the function. Now the challenge is, or the flip side on the question is that he's not giving us, let's say, two consecutive values of the function, right? He's giving us he's giving us f11, and then he's giving way down the line f15, and then he's asking us to backtrack and find f of 10. So you just have to work around this. Obviously you need to write a kind of equation, or a kind of expression for this, right? Means some variable analysis is required. You cannot just start writing, okay, f11 is known and f12, if it was known, we could just have calculated the values down the line. But here what we have to do, you have to take a variable, right? Let's say f of 10 is something we have to start solve for. It is, let's say, a, and then we have to come to use the further values given to us, right? So this question makes us work. F11 is 91, f10 I am taken as a variable which I am trying to solve. So what is f of 12? Okay, Sadin has got this. Yes, correct, Sadin. Good, very good. Right, so what will be f of 12? 91 plus a, right? What will be, right? We have to come to f15 and then make use of that, right? So f of 13, f12 plus f11, so a plus 182, right? We have to take two more steps. F of 14, sum of these two values, so a plus a, 2a plus this 182 91 will be 273. And finally f of 15, so sum of these two, 2a plus a, 3a, 273 plus 182 will be 455. So yes, finally we have the equation 3a plus 455 is 617. That gives us a as 54, right? 54. All right. Thank you for your participation. Good. Two people got this. Okay. Let's take this last problem for today. Another recent problem. Uh, hmm. I'll give you time for this. 2 minutes. Okay. Try this. All right. Very interesting. Very interesting. Okay. So let's discuss, people. Well, so this is the equation we have seen. So if the input, it is expressed as a product of two numbers, is the product of the value of the function at those two values, right? F of m into n is f of m into f of n for every positive integers m and n. So this equation is only valid for positive integers. And we are dealing with positive integers in the question also, no worry with that. And values of the function are also positive integers. So input should also be positive integer. Then the output values, which is f1, f2, f3, are also positive integers. F1 is less than f2, f of 24 is 54. 24, obviously we need to start breaking it down because we have to make use of this equation, right? So just write 24 as a product of two numbers. Now 24 can be written as the product of two numbers in many different ways. But let's separate it into one of the numbers being very small. Let's say 2 into 12. Okay, so this is f2 into f12. Now f12, I can again break it down as f2 in f of 2 into 6. So I can reuse this equation as many times as I want. So I can say this is f of 2 into f of 2 into 6, which is again f of 2 into this thing is again f of 2 into f of 6. And once again, I will again write 6 as 2 into 3 because I'm hell bent on using this equation as much as I want. Right, so f of 24 finally can be written simply as f of 2 into f of 2 into f of 2, which is the cube of f of 2 into f of 3. Right, so I think I think from the equation that we have and what we have just done, it makes sense to say that whatever input is there, just prime factorize that, and the value of the function is expressed in the similar manner. If 24 is 2 cube into 3, then f of 24 is f of 2 whole cube into f of 3. So this is something that you had to interpret, right? So this expression, the cube of f of 2, the cube of f of 2 times f of 3 is 54. So now comes the fact that the function values are also positive integers. So you need to write this 54 in this manner and do number matching on both the sides. 54 is 27 into 2. 54 is 3 cube into 2. So the 3 cube must match with the f of 2 whole cube. So we are getting what at that our f of 2 is 3 and hence our f of 3 is 2. Right? F of 1 is less than f of 2. Okay, so I'm not worried about f of 2, f of 1. I'm more worried about finding these f of 2, f of 3 because then that can help me to get this f of 18. So therefore, as we have understood the logic, f of 18, 18 being 3 square into 2, 18 being 9 into 2. So f of 18 should be f of 3 whole square into f of 2. F of 3 is 2, 2 square is 4, into f of 2 is 3, 4 into 3, 12. That's your answer. right? So even algebra makes us think, right? Even algebra is logical. Algebra is not just dry working with variables and equations. It is very much a thinking process. I love maths, don't mind. So I'll speak about that. Okay, so thank you, people, and we'll have one more conclusive session on algebra, which will be coordinate geometry. That will come up very soon, so watch out for that. And one very important thing: stay connected, stay in touch, and don't miss this. Don't miss the race to 99. It's just around the corner, August 2nd and 3rd. This is the schedule, right? So something that you will take a lot away from this 2 day session, right? And as I said, just stay connected with us. We also have now our mobile app, so you can uh, watch out for that and look out if that also helps you in your preparation. Thank you, people. Thank you so much. Thank you so much. I'll see you next time. Thank you. Bye bye.